So good afternoon, everyone. So here we are here to talk about the edge. Some of you might have heard Dave Johnson's session just a while ago. And here you're going to get a bit more detail about the edge. What is it? How do we define it? Why does it appear quite complicated? And what are we doing to simplify it? But I want to start by a question to you guys, by raise of hand. So how many of you have seen a UPS, a rack, or any IT system outside of a data center at some point in time? Great, just checking. Then this is for you, that's good. All right, so my name is Kim Povlsen. I'm running the software and digital services business in the secure power division of Schneider. And I'm so fortunate today to have Tripp Partain joining me in a few minutes. Tripp is the CTO of Edge and IoT at HPE. And he knows a lot about this topic. And he has some really good stories to tell. So look forward for that. He's going to join me in just a few minutes. Now, around the edge, I'm sure you've heard and seen a lot of hype around the edge that is going to revolutionize the internet. It's going to change everything. And you cannot probably achieve what we want to achieve around Internet of Things without the edge. I'm sure you heard all those things. But at the same time, no one really actually figured out how to properly define the edge. It's a bit of a mess. Everybody's trying, but you're going to find all these articles everywhere on how do we define the edge, what is the edge, what does it really mean? So I'm hoping at the end of this session, I'm trusting at the end of this session, you'll all walk away from here having a clear understanding about what the edge is about, how it's defined, what it really means, and how to solve the challenges that comes along with the edge. So I'm going to start with our simplified view of the world in respect to compute. So you're going to have very large compute centrals. This is the major large hyperscale and large enterprise data centers. It's growing like crazy and it's going to keep growing, right? It's the use of the cloud, everything's centralized. It's going to keep going. But you're also seeing these regional edge, as we call them. It's more, you see them more in urban areas, much more than you used to. It's still high compute density, but it needs to be closer to the consumer. And the use case for that is very often things like streaming on your smartphone, things like that. You're going to need that. Think Netflix, and so forth. And then you have the local edge. And here's where very often people get a bit confused, what is that? And I experienced an example just a couple of days ago when I was flying in here, what the local edge is really about. So I flew in from Boston. It was a long flight. As you know, all these flights has entertainment systems. You can watch movies and so on the screen in front of you. And I was sitting next to a young person, 16 years or so, a teenager. And it was quite funny for me because I'm a bit older and I grew up with slow computers. But this person was trying to watch a movie on the screen. It was really interesting to watch just from the side because he was trying to pick the movie and nothing happened for a few seconds, right? Those of you who have been on these planes trying to work with these entertainment systems, they can be a bit laggy, right? It can be a few seconds. But this young person wasn't used to that. They were used to smartphones, all the new technology. So this person kept clicking because of I guess it's not working. So when it finally responded, they moved on to the next menu and the next menu. So it took the poor guy 5 minutes to find the movies he wanted to see, even though he knew which one, right? And that is a good example of the edge. The edge is it's a lot of things, but it's very often about customer experience. You need low latency, you need something that's close to you need some strong compute to provide the customer experience everybody is now, especially the younger generation, that they are asking for. So when we define the edge, and when we talk about the edge on our side, we usually put them into these three buckets. You got commercial, you got industrial, you got telco. I'll give you a commercial example. Because again, when it comes to commercial, very often again, it's about customer experience. And my favorite example is fast food chains. And I love fast food chains because it's the kind of the place when you ask people about if they do fast food, nobody ever eats fast food. But for remarkable reasons, these businesses are thriving, right? Selling a lot of burgers, a lot of stuff. But one of the biggest one in the world I really like, because you get in there and now they have these, floor to ceiling kiosks where you can pick whatever you want and you can customize and you can get everything delivered to your table and you can go pick it up. And why does that has anything to do with customer experience? Is it faster? Yeah. Does it allow this specific burger vendor, if you like, a chain, to have less people behind the counter? Yeah. But also what it does is that you get exactly what you asked for. Because one of the biggest challenges with these fast food chains is that people get in there, I have an accent, I order something, and I can't tell you how many times I got something else than I ordered. It's probably my fault because I'm mumbling or whatever, but I leave the place with a bad customer experience. And these kiosks takes that away. There's a much higher probability I get exactly what I asked for because I typed it in, right? And that's another good example of retail edge, because those kiosks, they have to work all the time. So there you need resilience, you need backup, and if these things go down, they're in big trouble. Because yes, as I said, they have less people behind the counters, so they won't be able to manage the customers anymore. The industrial edge is different. This is very often a bit more compute that is needed. It's very often quite far out, away from urban areas and data centers in general. Think about an oil refinery. It's real-time processes. It's quite dangerous stuff. If something goes wrong, you can have explosions, people can get hurt. So here you need like very resilient, very strong compute as well in remote areas, and that's where the edge comes in also. And telco is still emerging, is still under definition, I'd say. But it's one to watch for. I really recommend everybody to watch for this one, because we have 5G coming, and we see small micro deployments at the cell tower level, at the base station level, the central offices is becoming data centers nowadays. And this is going to be a key driver for some of the things and the new technologies that we all expect is going to change our lives in the future. Autonomous vehicles, augmented reality, glasses where you can see stuff where you need to go. But that all has to be powered by the edge, and telco is where we believe a lot of that stuff will happen. So while it's still coming, watch out for this one. Good news, if there is any, right? There's a lot of challenges here, and there's a lot of complexity here. The good news is that the challenges we see across the board are quite the same, regardless if you're in commercial, if you're in industrial, or if you are in a telco section. It's things like no visibility, no monitoring systems, how do I manage these sites? Keep in mind, these are very distributed very often. They're all over the place. And if you don't have visibility, how can you manage? How can you do resiliency if you can't see what's going on? Standardization, again, we're talking about distributed sites. Take the fast food chain. They have thousands and thousands of stores. You can't have custom things in every single one of them. You need standardization, integration, and it just needs to be copy-paste from one to the next one, right? As I mentioned, there's going to be a ton of sites, and these sites won't have professional and well-trained IT personnel either. So you don't really know who's around your devices, your solutions. You don't really know who's tampering with them. How would you know, right? If it's in a grocery store, well, or a fast food chain, it's going to be the store manager that's going to manage the IT in the back room. Is he or she equipped to that? Most likely not. So what you need also, you need physical security to manage these kind of things. So these are the challenges, but there's something that is much, much worse. It's much worse. This is quite serious, because those challenges is incurring something we're starting to see, and there's a survey been done a few years ago that shows that 25%, that's 1 out of 4 of all IT personnel actually suffer from stress-related illness. Because there's not enough staff, they can't manage everything at once. So we're starting to see a real people problem here, and at least for me, that changes the home game. And then now it's just not only about business anymore, now it's something we have to go fix, right? There's people involved. This is a big deal. So what we've been doing to try to figure out how do we solve these challenges is really threefold, 3 things you need to do. And you've seen it a couple of times today, and we're going to keep bringing this message. It's integrated systems, easy to configure stuff, right? It needs to be super easy to configure it. It needs to be pre-assembled when you get it, and sometimes you need a complete turnkey solution. You need to have those options when you go for the edge. We can't do this alone, right? You need this ecosystem of partners that have all the bits and pieces that are the experts in all the bits and pieces that brings together such a solution. And you're going to need the monitoring and management software in a cloud-based architecture. Because again, if you don't know what's going on, how can you fix anything? You need the visibility. So if we go a bit into the integrated systems for a second, what I often hear people say, and people ask me when we say we have integrated systems, is that, all right, so are you losing up on flexibility? Because if you have standardization, what happens to the flexibility? So that's a very important factor to also keep in mind. This is what we're doing here. Because even though I've shown you those 3 different areas before, the environments these equipment's going to go into is going to be completely different, right? You're going to have harsh environments where you have things like dust and extreme temperatures, so you need specific solutions for that. You're going to have office environments where you would like maybe to have your micro data center, or whatever it is, to look like an actual piece of furniture, because it's not necessarily pretty stuff, normally, IT equipment. And there might be noise consideration to take into thinking as well. And then you have the normal or the traditional IT environments where you need specific sizes and so on, right? It needs to fit in, it needs to fit with the rest. And if we zoom in on the micro data centers, I think a great example, by chance something we announced this week, is the 6U micro data center that you might have seen over there. It's a really good case for the local edge, because in the local edge, what we see is quite rarely is there a dedicated room for IT. It's usually in a corner somewhere, or in the office, in the back office, or something where they're trying to put their IT systems. So this one is wall mounted. That goes on the wall. It doesn't take floor space. For resiliency, you got power, you got the cooling, you got the software that helps you understand what's going on. And as an add-on, you can even get the Schneider 24/7 monitoring. So we look at it for you, right? In order to increase the level of resiliency on this thing. So that makes things more simple. And again, we got the security piece to make sure that nobody's tampering with your systems, because again, you want to make it simple, you want to have resiliency, well, you got to know who's tampering with your systems and who's working on it. On the partnership, as I mentioned, nobody can do this alone, not even Schneider, and we can do a lot. So here you need, in order to build these type of solutions, you're going to need IT vendors, critical infrastructure vendors, well, that's us, and you're going to need system integrators to put it all together. And there's a quote from Worldwide Technologies, one of the biggest system integrators in the world, claiming that they're saving up to 40% of their time when they're deploying integrated systems versus not integrated systems. And in this case, time is money. As clear as that. So they're saving a lot of money and time by using the integrated systems. So it really makes a difference. So talking about partnerships, I'd like to invite Tripp to the stage. As mentioned, he's the CTO in HPE for Edge and IoT. And he's been working on the Edge before it was even called the Edge, I believe. So Tripp, tell us a bit about what HPE is doing around with these type of systems.
Thanks, Kim. So I think first, I'll start with a definition of the edge, right? We're all defining it as we go, but for me, it's really simple illustration. So let's imagine this stage is your data center, right? We've got our raised floor, literally, right? I've got my power, I've got my cooling, I've got my networking, I've got security, I'm scanning in, I'm scanning out, so I've got all the things I need to run IT professionally in a data center. All right, so now I'm going to walk to the side of my data center, I'm going to open the door. This may be a challenge for the camera. I didn't practice this with the camera, I apologize. I open the door to the data center and I walk out. I'm in the hall and I now close the door to the data center. At this point, I might as well be on the edge, because everything that I need, that I had designed and built into the data center doesn't exist. So regardless of the industry, and yeah, I just walked back through the door, regardless of the industry, regardless of what you're doing, regardless of what you call the edge, what's really driving the whole amount of work that's going on that companies are doing, investing at the edge, is how do I account for the things that are normally in a data center when I don't have a data center? And then from there, it has different forms and form factors and use cases and looks. So within HPE, we saw that and we said, okay, how do we take decades of building solutions that are meant to go in a data center and figure out how to take the best of those capabilities and apply that into solving problems at the edge. And so within that, we actually created a brand new category that's been defined now as a brand new category by both Forrester and Gartner of server types, and that's the Converged Edge system. And there's a couple of key characteristics about the Converged Edge system from HPE, and I want to kind of walk you through those. So you see the product line here, and I'll talk a little bit about that, but mostly I want to talk a little higher level about what the key commonality is across the product line. First and foremost, even though the 4000 looks just like a traditional rack server, everything that's called an edge line is engineered for harsh environments. Right? At a minimum, they will run in environments that are 0 to 55 degrees Celsius, at a minimum. If you get down to the extreme end with the 300, that expands out to -30 to +70. And so even though we have enclosures with cooling capabilities, and we'll talk a little more about that, it's important that the server is built to understand the data center, and the typical cooling may or may not be there when you start looking at edge environments. In addition to that, form factor is important, energy usage is important, shock, vibration, humidity. So now you start to get into the nuances that are different depending on which industry you're in and what your edge ends up looking like. So across the board, in order to be an edge line, these things are at the foundation, has to be. Secondly, it's an unprecedented amount of edge compute. So in most edge models that I've seen from lots of companies that are doing edge, you have a gateway to cloud or a gateway to data center model. Typically the gateway is ruggedized. It actually looks a lot like the EL300, to be honest, right? That's kind of the look and feel. You see the large heat sink on the top, you see some antennas, and inside of it, it probably has about the same capability as your laptop, right? A very similar spec set to the laptop. It typically runs an IoT or an edge version of software, and its main job is to grab data, maybe do a little processing, and then send it somewhere else for the real magic to happen. As we started talking to customers, we instantly found use cases where what I really need is the same thing I can do in the data center, I need to be able to do that at the edge. I may not be able to send the data. A, because there may be a latency issue. B, maybe I'm in a country where it's a compliance issue. I actually can't send the data from where it is to a data center, where my main data center is, or my cloud provider, actually their base is not within the same country set, so I've got compliance problems. You've got cost issues, you've got security issues, so there's a number of reasons why that model may not work. If you think about video as a sensor, any use case where you want to do real-time video analytics, the chances are you're not going to be able to grab the video, send it off somewhere, have that be processed, return the result, and actually be able to get any meaningful use from that data, because whatever it is already passed. So from an HPE standpoint, and again, I could spend a lot of time with specs, right? People who make servers love to sit around and give you all the specs about them, but I'm going to keep it simple enough to say we're using the same level Intel standard Xeon processors that are in data center servers, in the edge servers. In this particular form factor, the 8000, which sits half a rack wide, 5U tall, 17 inches deep, so it's literally the size of a toolbox. I can put it in the overhead compartment in an airplane. I could put 112 cores, 6 terabytes of memory, and 96 terabytes of storage, and be able to run that in a 0 to 55C environment as is, right? When I do that, I can run every single set of software that I can run in a data center now at the edge. It's not an IoT version, it's not a junior version, it's the full software. It's hypervisors, it's VMware certified. So anything that you've now standardized on in a data center, you can now deploy out at the edge. And so if you start thinking about one of the big challenges of IoT, where you've got an IT department and an OT department that normally don't work together, and you've got IT that has a lot of standards in place, and you've got OT that wants to be completely separated, being able to have a way to deploy what IT is already standardized and trained up on in these other environments actually helps these deployments move faster. Secondly, and this is an area that I think is just starting to grow, is the actual integration of OT technology into the same servers, into the same systems, into the same chassis. So what do I mean by that? Within each one of these, I have the ability to embed a direct control system, whether it's Modbus, whether it's CAN bus connectivity, whether it's direct GPIO connectivity, whether it's time-sensitive networking, or if your company uses PXI as a standard for those control systems, the 1000 and the 4000 are actually PXI compliant, so any certified PXI cartridge can plug into that and allow you to have this full data center class system plug directly into your OT system and talk in that native language. Right? And I'll give you a quick use case for that. There's a auto manufacturer that, I'm not sure I'm allowed to say the name, but I could just say they don't focus too much on gasoline, and in their spare time they land rockets and platforms in the middle of the water. But this customer actually uses these systems with a CAN bus card, so they can directly connect to the car door before it's been assembled and hooked up on the main line, so they can go ahead and do the internal CAN bus testing, so they can eliminate the QA issue as opposed to waiting until the car's been assembled. You connect up to the master unit, then you run the QA, realize it's a problem, take the car off the line, take the door off, go back, make the changes, put the door back on and keep going, right? So this customer found now I can replicate what the core CPU of the car would do in an edge line, running full QA test, hook it directly into the CAN bus connection on the car door, run the QA in real time at the local station and cut out all those rework steps, right? And so when you think about convergence of OT technology, I think back to when the iPhone first came out, right? If you actually look at the first iPhone, there was nothing about the hardware that was new. GPS chips existed, calculators existed, music players existed, cell phones existed, flat screens existed, music players existed. What Apple invented was converging all of those in the same form factor and then putting a layer of software on top of it that allowed those things to start interacting together. And that's what we're doing here in this convergence of OT. So I think this is an area that's just beginning. And lastly, it's integrating our data center class security and out-of-band management into every edge line. And what that means is there's a custom ASIC that's put into every one of these that has a separate network channel so that you can connect into this separate network channel, have full visibility into the entire stack that's running on the hardware, do full hardware management from the firmware layer up, but not actually interact with the business environment or the business network or the business connectivity. Where this again is really important, and the auto manufacturer that I didn't name but I think you may have guessed likes it, is they can now put this on a plant floor, hook it directly up to their OT networks, but have IT have a completely separate network channel to connect into and monitor. So the IT group is not interacting with the OT network or the OT group, which is one of the key challenges from a security standpoint that the IoT companies, that OT companies are worried about when they start having IT come in. So, but what's interesting here, as Kim comes back to the stage, is take the Edgeline 4000, right? So we've got this deployed, even though it's a ruggedized server, it was deployed and wall mounted in a control system at a joint customer that we have called TechSmart Chemicals. But what's interesting is even though the server's ruggedized and can handle the room, can handle the environment, it's in Houston, Texas, out near the water, and I'm not sure if you're aware, it's stormy in Houston. It rains, can rain a lot and flood, and there's a lot of thunderstorms. So there's power issues. So having the most ruggedized server in the world with the most compute capability in the world was great till the power went out. Now, power comes back on. Did the server recover? Yes. Was it rugged? Could it handle that? Yes. What happened though? The data was corrupted. Because when the power went out, you were in the middle of a software running cycle that didn't get to gracefully finish. So even though you can build servers for the most rugged environments, the other parts of the environment, like security, like power, like backup, are very important. And so it really, to your point of partnership, it really takes where we're making these new innovations, still combining with our partners so that the customer has a complete solution to not only handle the environment, but then handle the other characteristics of not being in a data center, like backup, like power, and resiliency.
Thanks, Tripp. I got a few questions before you move on.
Yep.
You talked a lot about IT-OT convergence, which is happening, which is super interesting for all of us. But you can kind of take that one layer, add the one layer to that. Is that when you take your solutions and integrates it with power and cooling and security and physical security as well. And want to touch a little bit on that, and also in respect to, I said it's resilience many times today, I'm going to say one more. So how do you see packaging it all up as a full solution, like the Micro Data Center we showed before, with the software, with your solution, power cooling, taking that, knowing that we are all, I think, recognizing HPE and the servers and IT in general to be resilient by itself. Mm-hmm. But how do you see that thing change when you're actually putting it all together along with the critical infrastructure?
Yeah, and well, when you start getting into non-data center environments, right, you have to deal with a lot of complexities because you're getting into business environments where uptime is critical, right? You think uptime's a big deal in the data center. If a factory goes down, they're not making money. If the email system goes down, you may not get the email from your boss for an hour, but it doesn't have the same impact on the bottom line. So the level of resilience, even though we talk about 5 nines and things in data centers and IT, the reality is uptime in an OT environment is even more critical because of how directly it's tied to the revenue stream. So you have to then plan, and you have multiple levels of technology coming together, so you really have to plan very deeply for how to integrate those. So some of the things we've been able to do together, as an example, is we work very closely with the micro data centers that Schneider Electric offers. We even have some that we offer in our partnership as well. So one of the things we've been able to do is to integrate some of the software that manages those environments. So we have a software package called OneView that gives you full insight into all the workloads that are running on our servers, as well as the hardware environments themselves. And then you've got EcoStruxure IT, which then tells you all about the physical environment within which these systems are running. Well, now we've integrated the two together, so from a single pane of glass, I can see all of that at the same time. So I've got visibility into the physical environment, the security of that, the status of the hardware that's running in that environment, and the status of the workloads that are running in that environment. So then things get to be interesting. So let's say I go back to the Texmark example, except this time I've got my edge line system and it's inside of the micro data center that has UPS backup, and it has EcoStruxure IT managing and monitoring the entire environment. Now what we're able to do and automate is when I get a power outage, and when I see that it's going to, for a certain amount of time, I'm draining through the UPS, and so now I'm getting to a time critical piece, not only can I make sure I got graceful shutdown of my workloads if that's what I want to do, the other thing we can now do is actually initiate an immediate backup of those VMs onto an adjacent system and have all of that automated based on the integration of our systems and your systems together, so we have a physical outage. We recognize now we're getting into danger zone from a time standpoint, so we automatically transfer those workloads and VMs to a system that's been set up as the backup, and we have no downtime at all, even though physically we do have downtime, right? So this is where an integration between the best of what we're doing can really help automate things for the customers.
So the integration, what I'm hearing is the integration is not only around what we're doing on the hardware level, it's also integration on the software level. It's really going to bring that resiliency, and that's why we're having this specific partnership. Because with HPE, with Schneider Electric, we can actually have all the bits and pieces to the puzzle to really make and solve this challenge. Thank you very much, Tripp. Yep. A few more things from me. I want to get a bit into the software, because when you're doing these type of cloud-based solutions, flexibility is the key. Because if we learned anything by doing this for a couple of years now, is that every single customer, every single partner works differently and have different operational models that they want to deploy when using these kind of solutions. It's very different. So, we created a platform and an architecture that can really allow you to mix and match different models together as you seem fit. You can pick one of them, you can pick multi of them, you can have some of them in one regional area and a geographical area, other models in other geographical areas. It all works together. And what's really happening, if you want to manage your own infrastructure, because that happens a lot, you get all the software and all the analytics and everything we have available. You get that as a plug and play software tool, cloud-based tool. You log into a website, very secure, do all the right things, helps you monitor predictive maintenance and check compliance around your systems. I'm going to get back to the compliance in just a second. If you want to have a partner to do things for you, like a managed service provider or multiple partners, they, because of this type of platform, they can get access to your system as well, and they can help you manage your infrastructure and your solutions as well. And finally, if you want to have Schneider to do it for you, if you do not have a preferred managed service provider, or you just prefer Schneider to do it, we can do it as well, right? We have 24/7 service bureaus that can do monitoring, they can even do dispatch, remediation, and help you worldwide. And to prove some of these things, I'm going to show you some of the numbers, because it's not slideware, it's something we've been doing for about 18 months by now, and there's a lot of momentum in here. So if you look at the number of customers we have connected and that are using this solution, we're already at 2,500 customers doing this every day, okay? We have almost 200,000 devices, assets connected. And an asset could be a microdata center, it could be a UPS, be a cooling unit, or something like that. We have 50,000 certified partners globally for Schneider that are IT experts. So they can help and drive this. And obviously we've been focusing on a number of specific geographies first, and in these geographies we already recruited, and we have 650 partners that are actively using this system every day to manage their customers. So a lot of these customers are managed by these partners. If you want to go for the Schneider solution, where Schneider actually manages and monitors your assets for you, and when it comes to remediation, we have more than 7,000 service professionals across the world that can come out, do the remediation, help you with your challenges. And this is, from a monitoring perspective, we have 6 regional service bureaus all around the world to make sure we have proper 24/7 language support, everything that is needed. So this is very serious, as you can see. It's a big investment on our side, and we're having a lot of traction on this. So, one thing that we're showing here, and that's what I promised to come back to, is the compliance piece. The compliance piece is something new we've done, because what we realized is that now that everything is becoming connected, think IoT, but very much on the edge as well, and in data centers also. Everything is becoming connected. That means the critical infrastructure, your UPSs, rack PDUs, cooling units, your HVAC, everything in the building is becoming connected too. And from a cybersecurity perspective, everything that is connected to a network, even inside the house, that is an attack surface for somebody may want to do intrusion to your systems. So it's super important that you're able to assess and understand the level of security in your critical infrastructure. When we talk about cybersecurity every day, most people are thinking about their laptops or their smartphones and their IT systems. But that's not enough. You got to do it also on the critical infrastructure. So what we're showing here, and what you can see at the booth, if you haven't seen it already, is a security assessment that assesses all your devices, all your critical infrastructure. It checks things like, are you up to the latest version of firmware? Do you have security gaps in the current version you're using? And because it's cloud-based, we're checking versus what is the actual latest firmware for these devices, right? Super important, you might have some serious security gaps in there. What about the protocols that are running between, the communication protocols that are running between the various devices you have? Are they up to the latest standards, or do they present a potential vulnerability as well for you? So we call it like compliance testing and security assessment, because you need to know how you're doing. And the coolest thing about this thing is actually usually not hard to fix. It's usually a firmware upgrade that can fix most of these things. But if you do not have a cloud-based solution architecture that is connected, globally to all your devices, you have to go to device by device by device by device and upgrade all these things. You don't know what's running on them most likely. You can't even check. And when you have to upgrade, it's very expensive and time extensive as well. But here you can do it in one click. You upgrade everything at one time, and all this turns green. There's a lot of red right here, right? Hopefully turns green, and you're in good shape. So, I hope it's very clear by now, but what you need to do these things are integrated systems, an ecosystem of partners, and a cloud-based architecture, and software and services. Thank you, guys. That's all. So before I leave, just want to check if there's any questions. We've got a few minutes left.
Hello? Okay. So security is always a question. Can you address security in terms of a cloud-based platform?
Yes, cybersecurity on the actual platform. That's a very good point. So I talked about security at the critical infrastructure level, but obviously, what we often see when we go to customers with this is that they have questions and expectations of clarity around what is security and when we start connecting our devices. So first thing you need to think about is what kind of data is actually being sent to the cloud. And in this case, it's pure machine data from your devices. That means temperatures, loads, what power are you having, right? What kind of cooling, what is the airflow through the cooling? It's all machine data around the devices, metadata, as we call it. And it's encrypted when it gets in there, 256 bytes encryption, right? However, and what's also important is that it's a one-way direction. It's always from your side, it calls home to the cloud. There's no way to get in from the other side. There's a very big distinction in respect to security. If you have an open port, that you can go the other way down. For our perspective, it's one way only. We also are providing penetration testing reports to anybody who asks under NDA, showing we have third-party penetration testing companies actually checking and testing our software every single day and the cloud-based solution to see if there are any gaps. And they measure how quick we close them, if should there be any, because all things are evolving all the time, new components in the cloud and so forth. And finally, we're working towards ISO 27001. It's kind of like, there's not a lot of cybersecurity stamps out there, but that's one of the certification that helps the customers understand that we really know what we're doing. So we're working towards it, and when I'm saying that, it's just because it takes a long time to get. Hope that answered your question. Yeah? If that's all, I want to thank you all for coming. Thank you, Tripp, for being part of this.
Thank you very much.
Have a great rest of the day. Bye.